Hello, this is Jennifer Martinez. In this video, we are going to look at page 45 in our notebook and complete section C.1 inequalities. So first, what is an inequality? It's a less than or a greater than or a less than or equal to or a greater or equal to. So let's go over the meaning of these. Let's start with the first one. What does this expression mean? It means x is less than y. It's right over here on the right side. It means x is less than y. So for example, if I make y a 2, x would be less than 2. So that means x would be things that are smaller than 2. 1, 0, negative numbers. In fact, to get a visual, it's nice to use something called a number line. And they're going to ask you to do that on some of these examples down below. So what I'm going to do is I'm going to start with 0. I'm going to just draw the x-axis. And I think I'll just stop there. And here is 2. What are the things less than 2? All the things smaller, like we said, 1, 0, even 1.5, all the fractions, 1.9. Here are all the things that are less than 2. The next one, what does the little line mean? Well, that means that x is less than or equal to y. So let's look at an example of that one. What if I change this? X is less than or equal to 2. I'm going to draw my number line again. We're still going to have, I'm going to shade everything smaller than 2. There's 2. But now 2 is included. So how I'm going to denote that is I'm just going to shade 2 also. Right? Notice that this is an open circle. Well, that's a solid. So that means everything that is smaller or equal to 2. The next one is a greater than sign. This means x is greater than y. And then we also have the greater than or equal to. So let's look at example 1 for that one. And notice the directions say to draw the solutions set on a number line. So again, I'm going to draw my number line. There's my -3. It's all the things that are, well, first equal to -3, so I'll make it solid. And all the things that are bigger than -3. What's bigger than -3? Well, it's to the right, isn't it? Because -2, I'd rather be -2 in the whole than -4 in the whole. So all the things on the right. Notice when it's less than, it's all the values on the left at that point. When it's greater than, it's all the values on the right. Do you have to be careful with that, though? Because you could rewrite, if you have, for instance, this example, x is less than y, that means the same thing as y is bigger than x. So you can switch this around. So that's only true when x is on the left. Let's look at B. So the last one. This is called a compound inequality. What it means is that y is between the x and the z. Notice how y is both greater than x, right? Because x is less than y means y is bigger than x, and x is less than z. So for example, if I drew a number line on part B, I'm going to put 0 on the right there to get to -10, and I'm going to count by 2's here. And we have that here's -10, and here's -2, and the t is in between. It does make sense. Because t is less than or equal to -2, but this one means t is greater or equal to -10. The shadings, this is an open circle, but this one actually is solid because the -2 is included. Finally, looking at part C, I'm going to put 0 on the left here so I can get to 7. what does this mean? Well, y is less than or equal to 3. There's the 3. It's included. And less than that, so to the left. And then this one is the same thing again as y is bigger than 7. So it's open and it's to the right. Notice the difference between B and C. This one is two statements. It's the opposite of in between, isn't it? So, and you cannot write that as a compound inequality. You just have to write it as two different statements. X is less than or equal to 3, y is bigger than 7. When you have something in between, you can write it as an inequality. It's more like an and instead of an or because it's both. So let's look at exercise 1. Exercise 1 talks about solving inequalities. Very similar to solving equations, but there is a difference. So let's fill out this table. So they just looked at the left side of the inequality here, the 10 minus 2x, and let's plug in a 0. So that would be 10. Plug in a 1, be 8. Plug in a 2, 6. Plug in a 3, 4. How am I getting this? Let's just show you one of these. 10 minus 2 times 3, for instance, that's that one, which is 10 minus 6, which is indeed 4. Plug in a 4, and then plug in a 5. Then we're going to look at this, and we're going to use this table to solve where is this expression bigger than 4. Well, it looks like the expression is bigger than 4. Here it's 10, 8, 6. So it's bigger than 4. These three values, these values. And notice, what is the x with those 4 actually values? Looks like the x is smaller or equal to 3. Very interesting. Notice how this switched. Let's do part B. How would we do this on our calculator? So let's go ahead and follow these instructions. Let's graph the expression y equals 10 minus 2x and y equals 4 on our calculator. So what would we start off with here? Oh yes, to graph we have to hit y equals. So we're going to hit the y equals button and we're going to type in 10 minus 2x. And then on the y2, let's type in a 4. Over here on the left are the instructions. So in y1, I typed in a 10 minus 2x, and y2, I typed in 4. So now what I'm going to do is I'm going to go to zoom. I'm going to hit zoom 6. If you remember zoom 6, let's do it again, was standard. The standard window. And it's going to give me a graph. Now I'm going to use the trace button and the little right arrow. And notice when I hit the trace button, what I'm looking for is the y's. This is the y. Notice how the y is 8 there. We're looking for where is the y bigger than 10. Or sorry, y bigger than 4. The y is bigger than 4 here, isn't it? And once I cross that line, you're going to see right here 2.9. Y is still a little bit bigger than 4. But now the y is less than 4. And the x, by the way, is bigger or equal to 3 now. So you can see, because it's a decreasing line, it does flip. Let's try exercise 2. Actually, you should pause the video and try exercise 2 on your own. Once you're done, resume. First, I filled in the table using this expression for all these values. How you get some of these weirder ones, like say maybe this one, I'll just practice on one of the decimals. 3 times negative 1.99. I just used the calculator and I got that. Now I'm going to use the table to see where this is less than 0. So notice it's not less than 0 here. Less than 0 means negative. These are the values where it's less than 0. Actually, not this one, is it? I went ahead and recircled that. It's actually only these values. So where is that? That looks like, if I look at the x, that looks like things that are less than, not less than or equal to, but less than -2. Notice how on this one, the inequalities did not change. Sometimes they change and sometimes they don't. We'll see when they do and don't in a minute. But notice this one, it switched, it flipped. This one, it did not. So go ahead and try that on your graph. So in y1, I'm going to type in 6 plus 3x, and y2, I'm going to type in 0. Again, I'm going to choose zoom, standard. Number 6 is standard. And you can't see that y equals 0 because it's right on the x-axis. But we still could hit trace. And I'm looking for where the y values are less than 0. So I'm going to this time do the left arrow. Why am I choosing the left instead of the right? Because the 0 is closer there. I'm trying to go down. And notice how all the y's are positive. So it's not these values. Where are the y's? Oh, there's a negative value. So it looks like, okay, it's smaller than -2. Again, remember, smaller than -2 means larger negative values, because -3 in the whole is a worse place to be in than -2. I know that's backwards. But there it is. It's all the things that are smaller than -2. Now you can solve these algebraically. Let's go ahead and do that. You can solve these like pretend there's an equal sign here, and what would we have done? We would have subtracted 6, and then we would have divided by 3, and you see that you get the same answer. All is good. All is good because the sign, the direction of the inequality, did not get flipped. But let's go ahead and solve this one. Let's go back to exercise 2 and solve this one. Solve algebraically. If you remember, this is what we were originally trying to solve. So again, if I pretended there's an equal sign, I would have subtracted 10. So let's go ahead and do it. See what we get. And then divide by -2. You still get the answer here. You get 3, but this one, the answer, the inequality was flipped. Why is it flipped here? Well, it's because of the negative. If you remember the decreasing, the larger the negative, the smaller the number. So when you have negative values here, because of this -2, when you multiply or divide by a negative, you're going to flip the inequality. Let me write that down. Let's see, where can we write that down? Let's do it down here. Here's the rule. When you multiply or divide by a negative, we must reverse the direction of the inequality. This one, the first one we divided by a negative, so we reversed it. For the second one, we did not divide by a negative. Even though the answer was negative, it's the actual operation, so you did not flip it. Let's see this with the following 2 examples. Let's look at 2x. Let's solve. 2x is less than or equal to 6 versus -2x is less than or equal to -6. Both answers, you get a 3. So let's make that +6. Get a +3. Let's do this one. The answer is a +3, but this one is a negative. It's going to flip. It does make sense. Let's see why. Let's go ahead and make a table of the left side for both of these. So this would just be a 2, 4, 6, 8, 10. We're looking for it's less than 6. Oh, makes sense. But let's do the same thing for a -2x. So this would be a -2. Notice what happens when the values are negative. The larger the negative, the smaller the number. So we're looking for things that are smaller than -6. What's smaller than -6? Oh, -8. I'd rather be 6 in the whole than 8 in the whole. Notice how it is flipped.